let's look at an example on the empirical formula. An organic compound on analysis yields 2.04 grams carbon, 0.34 grams hydrogen, and 2.73 grams oxygen. Calculate the empirical formula. There's a big part of the question. It says if the relative molecular mass of the compound is 60, see, because I have to note it so that you can see how important it is. Calculate the molecular formula. Now, in solving empirical formula, you go in steps. First, identify the mass of the elements. Then second step is the mole. Then the third step is the mole ratio. Now, what is the mass of carbon? The mass of carbon is 2.04. The mass of hydrogen is 0.34. And the mass of oxygen is 2.73. So my next step now is the mole. Mole is equals mass over molar mass. So this becomes 2.04 over 12. This becomes 0.34 over 1. Why this becomes 2.73 over 16. This becomes 0.17. That's what is equal to. This becomes 0.34. That's what is equal to. Why this becomes 0.17. Now, this is the mole of carbon, mole of hydrogen, and mole of oxygen. What's the next thing? The next thing is mole ratio. The next thing is mole ratio. How do we solve for the mole ratio? You check, compare which is the least mole of the available moles, then you divide by the individual moles. So now among 1.7, 0.34, and 0.17, I have 0.17 as the least mole compared to each of them. This and this are the least mole, so I will divide through by 0.17. So I have here 0.17 over 0.17. That leaves us with 1. I have 0.34 over 0.17. That leaves us with 2. I have 0.17 over 0.17. That gives us 1. So it means our empirical formula is now equal to C is 1, H is 2, O is 1. That becomes our empirical formula. Now remember what we did in our previous lesson. We said empirical formula, bracket N equals relative molecular mass. That's what we said. So in solving question number 2, our question says if the relative molecular mass of the compound is 60, calculate the molecular formula. So now I know my empirical formula. This is my empirical formula. So I will say CH2O bracket N. N is the number of repeating units of the empirical formula in the molecular formula. The molecular formula is the actual formula. So to know the number of empirical formula in that molecular formula, that's what this N is doing for us. Because more than one compound may have the same molecular formula, but do not have the same repeating units in of that empirical formula in its molecular formula. So now CH2O will be equal to 60 as given us in the question. Now what is C? C is 12 plus what is H? 1 times 2 plus 16, all in bracket N equals 60. If you add up this, you'll be having 30 bracket N equals 60. Therefore, N equals 2. So if my N equals 2, I'll come over here to conclude it by saying empirical formula, bracket N is equal to molecular, is equal to our molecular formula. So therefore, I have CH2O bracket 2 is equal our molecular formula. Now, what is the next thing? It becomes C2H4O2 is now our molecular formula. This can also be expressed as CH3COOH is our molecular formula. So it means that this is equal to 60. This is equal to 60. So this is the molecular formula of the organic compound we are talking about. So that will leave us with this equation that empirical formula, empirical formula, bracket n is equal to RMM is equal to molecular formula. Take note of this. It's very important. Now let's look at question number 2. A gaseous metallic chloride MCl. So it means that my elements are M and Cl. Those are my two elements that I have for this compound. MClX consists of 20.22% of M by mass. So the percentage of M is 20.22%. Now, they just gave me that of M. They did not tell me what is the percentage of chlorine in the compound. It's simple to get. So now I'll come here to say percentage composition. Percentage composition. In my previous question, I used mass because mass was what the question gave to me, but now the question is giving me percentage composition. So now, what is the percentage composition of N? Is 20.22. What about of chlorine? It would be 100 minus 20.22. That will become 79.8%. So I now know the percentage of Cl and the percentage of N. What's the next thing I should do is to get the mole, is to know the mole. Now this will become percentage composition over molar mass. So this is 20.22 over what was the molar mass of N? Is 27 over 27. Then why this becomes 79.8? What's the molar mass giving us? Is 35.5 over 35.5, where this will give us 0.75 and this will give us 2.25. Now these are the moles when solved. These are the moles when solved. What's the next thing I will look for? I will look for mole ratio. I will look for mole ratio. Now, in looking for mole ratio, we said we will check which of these is the least mole because I will divide each mole with the least mole. So this is smaller than this, so this will be my least mole. So I will say 0.75 over 0.75, which equals 1. Y over here, 2.25 over 0.75, which becomes 3. So now my empirical, my empirical formula is what now? Is M1, no need to put it there, then Cl3. So that becomes the answer to this question. Thank you. Now let's look at question number 3. A hydrocarbon contains 82.8% carbon and has a relative molecular mass of 58. What is the empirical formula? Question 2 says, the big part of the question says, what is the molecular formula? Now, very simple. We go with it again, and this time we say the compounds we have is carbon, carbon, now is an hydrocarbon, so it's carbon and hydrogen. Now, what's the next thing? We're giving the percentage composition. What was the percentage composition? That's what they gave to us. Percentage composition of carbon is 82.8, while that of hydrogen will be 100 minus 82.8, and that is 17.2. So, because this was 82.8, to get this, we'll subtract it from 100 and we have the available one, because the percentage of hydrogen plus the percentage of carbon must equal to 100%. Now, the next thing we said we'll look out for is the mole. What is the mole? Mole is now percentage composition over molar mass. That's what we are using. So this becomes 82.8 over 12, while this becomes 17.2 over 1. Now, if you check out this, you'll be having 6.9, then this will be equal to 17.2. Now, the next step is now to get our mole ratio. Our mole ratio. Mole ratio is we divide each mole with the least mole when compared. The least mole is 6.9. So I will say 6.9 over 6.9. That is 1. Then this will be 17.2 over 6.9. That will be 2.5. Now it is absurd, it is a crime at this point to say that empirical formula is equal to 1:3, because you round off 2.5 and make it 3. This is not correct. This is not the way molecular and empirical formula is solved. No. Rather, what will you do? Empirical formula, empirical formula will say, as what we have is 1:2.5. What will I do next? Convert this guy to fraction. Is 2.5 over 1. Take this out. It's not 10. So I now have it as 25 over 10. This here is 2. This here is 5. So I have 1:2, 5 ratio over 2. So I will say multiply through by 2. Multiply by 2. Why? Because empirical formula is a whole ratio number formula. You don't approximate when it is not at most 2.9 something or 2.89. You don't approximate it to the nearest whole number. You cannot approximate such a value to the nearest whole number and call it the empirical formula. Instead, you continue the solving, and multiplying by 2 will now give us 2:2 times 5 over 2, which is now equals 2:5. So the actual way the empirical formula of this compound will be expressed is C2H5, not CH3, or rather C2H5 is our empirical formula. So our empirical formula is C2H5. What's the B part? The B part says we should find the molecular formula. Remember, empirical formula C2H5, all in bracket N, is equals 58. Is giving us here. The relative molecular mass is 58. So it becomes 12 times 2 plus 1 times 5, all in bracket N, is equals 58. This becomes 24, 24 plus 5, n equals 58. This becomes 29 in bracket n equals 58. N equals 58 over 29. That becomes 2. So it means that I now have it as C2H5 all in bracket N equals molecular formula. Now, what is our molecular formula? It becomes C2H5 all in bracket 2, which equals C4H10, and that's brother butane. So, the molecular formula of this question is C4H10, but the empirical formula of this question is C2H5. Take note, we said it cannot be rounded off to the nearest whole number if it's not at most two or at least 2.9 or 2.89. The proximity must be very close to the nearest whole number before you can have the courage to approximate. Thank you. Now we will looking at question number 4. Question number 4 is a more advanced question on the empirical formula. Why? Because it says find the empirical formula of an organic compound which after combustion gave 0.6875 grams of carbon dioxide and 0.562 grams of water. What this implies is that they did not give us the mass of carbon, unlike the ones we've been solving, where the mass of carbon will be given and the mass of hydrogen will be given, or the mass of oxygen. That's not what they gave to us here. They gave to us the mass of carbon dioxide and the mass of water form, meaning I will be the one to get out the mass of carbon in this carbon dioxide and the mass of hydrogen in this mass of water. So our first job is to calculate for the mass of carbon in this mass of carbon dioxide and the mass of hydrogen in this mass of water. So this is a case involving combustion of hydrocarbon. So I would say mass of carbon in CO2. Now remember that CO2 is a compound. CO2 as a compound equals 12 plus 16 times 2 and is equals 44. So it means that 12 grams of carbon is present in 44 grams of carbon dioxide. That's what it means. So I will say 12 grams of carbon is present in 44 grams of CO2. Therefore, X gram of carbon will be present in 0.6875 grams of carbon dioxide in 0.6875 grams of CO2. What will that be my X? My X is equal to 12 times 0.6875 over 44. So my X will be equal to 0.1875 grams of carbon. So now I have the mass of carbon. Now let's look for the mass of hydrogen in the mass of water given. So now I'm looking for mass of hydrogen in H2O. Now, how is H2O? This is H2O equals 1 times 2 plus 16 equals 18 grams. So it means that 2 grams of hydrogen is present in 18 grams of water. 2 grams of hydrogen is present in 18 grams of water. So in this water, 2 grams of hydrogen is present in 18 grams of water. So I would say 2 grams of H is present in 18 grams of H2O. Therefore, X gram of H, X gram of hydrogen will be present in 0.5625, 0.5625 grams of H2O. Now, what is X? X will be equal to 2 times 0.5625, 5625 over 18. What is X equal to? X is equal to 0.625 gram of hydrogen. 0.625 gram of hydrogen. Now we have the mass of carbon, we have the mass of hydrogen. This is of hydrogen. Now, but if you look at the question, it says find the empirical formula of 0.5 grams of an organic compound. So what you do now is this. You ask yourself, the mass of carbon, the mass of carbon plus the mass of hydrogen is equal to what? Because the mass of the organic compound is 0.5 grams. So it means mass of carbon is, the mass of carbon is 0.1875 plus mass of hydrogen is 0.0625. If you add up the rate, you have it as 0.25 grams. That means that there is an extra element in this organic compound that is unknown to us. So it means there is another element which is oxygen in the organic compound. Therefore, if the organic compound, if the organic compound is, if the organic compound equals 0.5, and the mass of carbon and hydrogen is 0.25, it means the mass of the oxygen will be 0.5 minus 0.25, which will not be 0.25 grams. So I'm trying to tell you that our compound has carbon, it has hydrogen, and it has oxygen. These are the three elements that are in the compound. What is the mass? What are the masses of these elements? Mass of carbon is 0.1875. Mass of hydrogen is 0.0625. What about the mass of oxygen? It's now 0.25. Now, how did I know that there's an extra compound in the organic compound? Is because the total mass was not equal to that of carbon and hydrogen. Hence, being an organic compound, there is oxygen in it. What is the mole? The mole will now be 0.1875 divided by 12, while here it will be 0.0625 divided by 1, while here it will be 0.25 divided by 16. So this will give us 0.0156. This will give us 0.0625, while this will give us 0.0156. Now, what is the mole ratio? The mole ratio will not be the mole ratio will be, which of these is the least mole? This is the least mole. So it means, sorry, this is the least mole. So I'll divide through by 0.0156. So I have 0.0156 over 0.0156. I have it as 1. I have 0.0625 over 0.0156. I have this as 4.006, 4.006. Then I have this as 0.0156 over 0.0156. that will be equal to 1. Now my empirical formula, my empirical formula will be equal to 1 ratio. This is 4. This is allowed as 4. Then ratio 1. So it means it is H4O. That becomes the empirical formula of this compound. So this is a question involving combustion reaction, and we have to get our carbon from carbon dioxide. We got our hydrogen from water, and we now compare with the total amount of the mass of the organic compound and realize there is an extra element present, which was oxygen, and we got that by subtracting the combination of carbon and hydrogen from the total of zero point 0.5, and we got to 0.25. Then from there, we did our normal empirical formula and we arrived this as an answer. Thank you.